So we solve that problem. A supersonic flow at the Mach number 2 temperatures are minus temperature 300 minus 300 Kelvin. So pressure the 1 atm density 1/2 kilogram per meter cube. Approach in the compressor corner. A attach oblique shock with the weight angle minus 45 degrees is formed at the corner. Find the normal mesh number upstream and the downstream at the shock, and so also find the M2, P2, PO2, and assume the gamma equal to 1/4. So that them equations are we can write down the equation. So in this case, we have to assume that the theta, beta, and the M relationship. We have to utilize the theta, beta, and the M relationship. So this relationship equation have to be utilized. Theta, beta, and M relationship. So in this case, so from the equation shares a relationship of the theta, beta, and the M, then we can write down this the equation. So that will be the so tangent theta is equal to the 2 multiplied 4 into square root of 2 square minus 1 divided by 4 minus 1/4 plus 0 plus 2. So you got a 0/263. So that equation you got. So in this case, theta equal to 14/7 degree. So the m u1 is equal to m1 sin beta 2 is equal to root 2. So the mu2 square equal to this 1 plus 0.2 multiplied by root 2 square divided by the 1/4 minus 2 minus 0.2. So 0.538. So the m2 is equal to m02 divided by sin beta minus theta. So you got the 1/45. So those equations those relationship equation we can get it. So this is for this dimensions equation. So relating to this the tunnel. So the test tunnels are when the tunnels are the pressure passing through. We have to write down the those equation. So this is the supersonic flow the mesh number 2 temperatures are minus 300 Kelvin pressure 180 density 1/2 kilogram per meter cube compressor corner oblique shock ကိုတွေ့ရမှာဖြစ်တယ် weight angle minus 45 degree เนาะ corner မှာဖြစ်လာတာဖြစ်တယ်အဲ့တော့မှဆိုရင်သူ max number ကိုတွေ့ရမယ် M2 P2 PO2 ကိုတွေ့ရမယ် gamma 1/4 ဖြစ်တယ်အဲ့တော့ theta ရဲ့ beta ရဲ့ m ဆက်စပ်မှုကနေပြီးဘယ်လိုညီမကြီးရေးလို့ရတော့ tangent theta equal to 2 multiply 4 multiply root 2 square minus 1 divided by 4 minus 1/4 plus 0 plus 0ဆိုရင်ဒါ 0.263 ကိုရမယ် theta 40/74 degree ကိုရမှာဖြစ်တယ် mu1 ဆိုရင် m1 sin beta ဖြစ်တဲ့အတွက် square root of 2 ရမယ်အဲ့တော့ mu2 square equal to 1 plus 0.2 multiply root 2 square divided by 1.4 multiply 2 minus 0.2 ဆိုရင် 0.53 ကိုရမယ် m2 ဆိုရင် mo2 divided by sin beta minus 3ဆိုရင် theta ဆိုရင် So in this case, P2 is equal to 1 multiply 1 plus 2 multiply 1/4 divided by 2/4 multiply 2 minus 1 so 2/17 atm. So PO2 by P2 is equal to 1 plus gamma minus 1 divided by 2 m2 square power gamma by gamma minus 1. So from this one you got the PO2 is equal to 2/17 multiply 1 plus 0.2 multiply 1/4 by square the 4 power 3/5 so 7/4 atm. And you might say be the gamma so not m2 so no so mo2 divided by sin beta minus theta so 1/4 ya me p2 so 1 plus multiply 1 plus 2 multiply 1/4 divided by 2/4 and multiply 2 minus 1 so 2/17 atm. PO2 by P2 so 1 plus gamma minus 1 divided by 2 and 2 square the whole power gamma divided by gamma minus 1 so P02 so 2/17 multiply 1 plus 0.2 multiply 1/4 by square power 3/5 so 7/4 area ကိုရပါဖြစ်တယ် So then we are talking about the fundamental of the VCR flow. The VCR flow was included in the momentum equation. So in the momentum equation, we included the VCR flow. So in the VCR flow, additional normal and the shear stress due to the viscosity must be taken into account. So because of the VCRs there is a viscosity additional momentum and the viscosity can happen. So the Navier-Stokes equation describes the motion of the compressive air, VCR fluid, and the body's force. Heat transfer and the possible and unsteady effect. those equations are utilized in the Navier-Stokes equation. The Navier-Stokes equation for the Visier-Flow equation. So the Visier-Flow blossom that described in the following section. The Dimaswing Cassia, Sika the Yeda Sisemu, the Sika the Yeda Sisemu Amaswing, I Sika Mua, Sika the Jamulu, no, Tapio Apo, no. Shobia are the people are Shobia are the people are Navier-Stokes equation, a Shobia are a don't you be a Shobia are the Navio, the flu pressure are the Navio, heat transfer the body force, and I read when you're Doyama today at a Visier-Flow, fundamental in Pijari. Write down as a Visier-Flow equation. For the Visier-Flow, two-dimensional Poisson-Ulisse flow equation have been utilized. So the equation is a rho del y minus a p plus a db by dx del h multiplied del y minus a tau ys del h plus tau ys plus tau ys by del y multiplied del y multiplied del h equal to 0. So straight is equal to the del theta 2 minus del theta 1. And now that's when a Visier-Flow equation two-dimensional possibilities of flows and imagine Yima Chit and imagine as we the rho p dy minus in the Queen Masway p plus a t b by t is a t is multiplied del y minus a tau y is t is plus tau y is plus tau y is by del y multiplied t is equal to 0. So imagine Yime and Australia as we del theta 2 minus del theta. The EHY is equal to the del V by del H plus del U by del Y. So the equation we can calculate. So this is the incremental angle. So the tau HY is equal to U multiply del V by del H plus del U by del Y. Now, seven imagine you either come out so no EHY so yame. I must say that del V by del H plus del U by del Y no yame. Tau Y is equal to U multiply del V by del H plus del U by del Y. So imagine that yama today. I must say because we coefficient the equation can calculate the tau HY equal to tau YH. So tau YH is equal to the tau HY equal to mu multiply del V by del Y plus del V by del Z, or the tau Z is equal to the tau AZ equal to mu multiply del U by del Z plus del V by del H. So the tau AH is equal to the lambda del V plus a 2 mu del U by del H. Tau YZ equal to lambda del V and plus a 2 del U 2 del V by del Y and tau now YZ equal to the lambda tau del V and plus a 2 U del W by the del Z. Those equations are for the normal structure equation or the Visier normal structure equation. And imagine that we the commas we not do about this way. The three-dimensional flow element imagine so X Y and Z is here. Tau HY as we tau Y is needed. And tau Y is as we tau HY equal to mu multiply del W by del Y plus del V by del Z and needed low. Tau Z is called tau is and needed mu multiply del U by del Z plus del W by del H and needed. And so we three component normal stress for the three component to the Visier flow imagine tau HY as we lambda the del V plus 2 mu del U by del H tau Y Z by the way tau AH as we lambda del V plus 2 mu del U by del H and now we tau lambda Y S equal to tau YZ equal to lambda del V plus 2 U divided by del V by del Y and tau Z is equal to the lambda del V plus 2 U del W by del Z ဆိုရင်ညီမကြီးနဲ့ဖော်ပြလို့ရတယ် The equations are we continue. So hydrostatic pressure equation can be written so minus a del V by del H plus del Y del H plus a del Y H divided by del Y multiplied del H by del Y equal to 0. So therefore the del V by minus del V by del H plus mu into del 2 U by del Y square equal to 0. Then mu del 2 U by del Y square plus equal to the del V by del H. So then mu del U by del Y equal to del V by del H Y plus C1. So that will be the equation, the general equation. Except in imagine you the comma so minus del p by del h ဒါပါဆို hydrostatic pressure ညီမကြီးရေးမယ်ဆိုရင် minus del p by del h multiply del h del y plus del tau y h by del y multiply del h del y equal to 0ဆိုရင်ညီမရေးရမယ်အဲဆက်ပြီးရေးတဲ့အခါမှာဆိုရင် minus del p by del h plus mu del 2u by del y square က0နဲ့ညီမယ် mu del 2u by del y square equal to del p by del h နဲ့ညီတယ်လို့mu del u by del y equal to del p by dp by dx y plus c1 ဆိုတဲ့ညီမကြီးနဲ့ရေးလို့ရတယ်by that equation we have to integrate. So by integration, we follow the integration step. So mu u equal to del dp by dx multiply y square by 2 plus c1 y plus c2. U equal to y square by 2u mu multiply dp by dx plus c1 by mu y plus c2 by mu equal to the 1 by 2 mu multiply dp by dx y square plus ay plus b. So that equation we got. And now integrate the comma so if you have blue yellow so mu u equal to dp by dx multiply y square by 2 plus c1 y plus c2 so yame u equal to y square divided by 2 mu multiply dp by dx plus c1 by mu y plus c2 by mu so 1 divided by 2 mu dp by dx y square plus ay plus b ဆိုတဲ့ညီမကြီးကိုရမှာဖြစ်တယ် the equations are what you call is a equal to minus 1 divided by 2 mu dp by dx multiplied by h. Then mu equal u equal to the 1 by 2 mu dp by dx are y square minus 1 by 2 mu dp by dx are hy equal to 1 by 2 mu dp by dx are y square minus hy. So therefore the del mu by the del y is equal to the 1 by 2 mu multiplied dp by dx multiplied 2y minus h equal to 0. So the integrate u maxima is a minus a square by a mu multiplied dp by dx. Now, so imagine share the comma so a so minus 1 by 2 mu dp by dx multiply h so ya me a set share the comma so u equal to 1 by 2 mu multiply dp by dx y square minus 1 by 2 mu multiply dp by dx hy equal to 1 by 2 mu multiply dp by dx y square minus hy. That will tell you by del y as 1 by 2 mu multiply dp by dx multiply 2y minus h 0နဲ့ညီတယ်အဲ့ဒါဆိုအများဆုံးဖြစ်တဲ့ time u maxima equal to the a square by 8 mu multiply dp by dx ဆိုတဲ့ညီမကြီးကိုရမှာဖြစ်တယ် Question that we finally can that average velocity mu uab is equal to 1 by h 0 to integrating 0 to h u dy equal to 1 by 2 mu h dp by dx integrating 0 to h y square minus hy dy equal to minus 1 divided by 2 mu h multiply h mu u maxima by a square multiply h square divided by 6 equal to 2 by 3 is mu as maxima. And also the locus case coefficient can also be written so c tau is equal to the rho UAV divided h multiply mu. So therefore that equation is a two-dimensional Cartesian equation is del u by del h plus del v by del y equal to 0. ဆက်ပြီးညီမချင်းကိုရှင်းတဲ့အခါမှာဆိုတော့ UA average velocity อ่ะဆိုရင် 1 by h က integration 0 to h u dy ဆိုရမယ်အဲ့ဒါဆိုရင်ဆက်တွက်တဲ့အခါမှာ1 by 2 mu h multiply dp by dx so integration 0 to h y square minus hy dy ကဘာလဲညီလဲဆိုရင် minus 1 by 2 mu h multiply h mu u maxima divided by a square ဒါဘာလဲဆိုရင် a square divided by 6 so 2 by that u maxima လို့ရမှာဖြစ်တယ်ဒါ locus scale coefficient ကြတော့ rho uav h divided by mu လို့ရမယ်အဲ့တော့ two dimension ညီမချင်းတော့ del u by del h plus del divided the equations we had to utilize the steady flow and the default of the body forces are the momentum equation. So those momentum equations are you can see on the equation 3.16 and the 3 so the equation can also be simplified. So you can see on those slides. အဲ့တော့ဒီညီမချင်းကဆို steady flow ဆိုရင်တော့ဒီမှာဆိုရင်အဲ့ညီမချင်းကိုပြန် simplify လုပ်တဲ့အခါမှာဆိုရင် equation 3.16 ကိုရမှာဖြစ်တယ်အဲ့ဒီ 3.16 ကြောင့်ဒီ slide ပေါ်မှာတွေ့ရ And the wind dynamics and the various basic elements. So we have to utilize the wind dynamics. So the wind dynamics are the instrument in which the airflow is generated in the test session over the designer speed range and the loss of cost by the airflow through the tunnels are minimized in order to ensure efficient operation of the tunnel. The test sessions should be able to accommodate the various kinds of the models which need to be tested to determine that they are aerodynamic characteristics. It may involve the flow visualization using the various means like the smoke, dust, and laser sheet, etc. Pressure measurement using a manometer, pressure sensor, pressure sensitive plate, and a measurement of the force and the moments using a mechanical balance or strain gauge. The balance may be kept outside the test section or the inside it. Crossing the is called the external or the internal balance. The prerequisites of the usability of wind tunnel for aerodynamics. Maybe there's a similarly the law can be applied so that the result of the models in the wind tunnel can be transferred to the flow above the full scale configuration, especially to the flow above the aircraft in the free flight. In general, the complex similarity is very difficult to attain in the single experiment. For this reason, it is necessary to determine the similarity parameter which of the greatest importance for the problem to be investigated, and only obey the corresponding similarity rule in the experiment. In the aerospace applications, the two most important similarity parameters are mesh number and the Rayleigh number. As of now, wind tunnel you don't do the wind tunnel as we the not more tunnel them the camas way dynamic to aerodynamic below facet of the dynamic below bit to some of the no laser sheet GP or dynamic PR dynamic PR the manometer pressure sensor pressure sensitive pain dynamic dynamic force dynamic Samusaya Nimamushi dynamic strain gate in the dynamic dynamic camas way at the premium Bonamo Moody Bioma Dilemia later the Canon Boani come up below 10 minutes or dynamic I don't dynamic camas way a dynamic no the air flight the free flight the Yabu Lure and I love the Luate no these are the snow new don't you me Eddie Camas a Diga Jazz or Mechnamane Rayleigh number Shama basis experiment in the low speed of wind tunnels. So that we are going to spend some time in the landing. So experiments design and perform a very few basic elements. So experiments in the low speed of wind tunnels start with the initial calibration. This involves obtaining the relationship between the speed of the RPM of the fan and the test section air velocity. Application of the pitot-statics tube was explained, and so in obtaining the airflows and velocity, this instrument will be placed at the middle of the wind tunnel test section, and the stations and the static pole should be connected to the two limbs of the manometer. The stations of pressure being the highest pressure in the flow field will exceed the static pressure when the tunnel is running. Thus, the liquid fluid in the limbs connected to the stations of pole would go lower than the liquid level in the static pressure limit. If the difference in the height between the liquid columns is AH, density of the liquid is ρ1, then we can write B0 minus BH is equal to the AH rho I multiply G. Therefore, the equation can be written as the UH is equal to square root of the 2 rho root 2 delta HP rho IG divided by rho H. Every come as we do not low speed wind and low speed wind and Masway, Liga Jazz was we do a PR dynamic a season and the PR dynamic, a liquid in but the pressure dynamic, now your density to dynamic. And then we'll do dynamic Hamasway, no. I will dynamic water less to manometer less set will be dynamic. Pero you imagine they are to Yam less raw. P0 minus PH so in there's H rho PI. P0 minus PH go to H rho LG so when you imagine Yeme, I come the UH go to square root 2 H rho LG divided by rho H when you imagine Yam.